In this video, we'll talk about normal distributions and specifically the z-score. So when we're talking about a z-score, what you're looking for in the problem is something like standard normal distribution or a specific reference to z-score, and you will always have a mean of 0 and a standard deviation of 1. So this is what it means to have a z-score or a standard normal distribution. A mean of 0 and standard deviation of 1. So when you think of normal distribution, you want to go ahead and make a normal distribution. So your bell curve there, you can put our line here. And remember, normal distribution goes to negative infinity very slowly, and it never crosses the x-axis. And the same way going this way. And now our normal distribution is symmetric about the mean, so 50% probability is above the mean and then 50% is below. Your mean is in the middle, so your standard deviation, if you just went above 1, and you can go below -1, and this should remind you the empirical rule. So in between these two lines right here, we would have 68% of our probability, and then we can go 2 standard deviations above the mean, 2 standard deviations below. Remember, that's 95% of the data points lie between those two values. And we can go up to 3 and down to 3 standard deviations. But now everything fits into the empirical rule. So we need to figure out how we're going to solve problems if we don't have exactly 1 standard deviation away or 2 or so on. So in this problem, we have a z-score of 0.83. So it's telling us that we're 0.83 away from the mean, which would be right here. Okay. And what it's asking for you to find is, if we draw a line here, the probability that the z-score is less than 0.83. Okay, so this is this whole area here. Now to do that, we could use the tables, or we can use a function in Excel. So what we can do is we could go to Excel, and then you want to choose statistics if you haven't done it, or statistical if you haven't done it already. And we're going to scroll down to norm. And we have different ones here. So norm.dist and norm.inv, those always work. These are specific to the standard normal distribution. So for these two right here, the S here, s.dist and s.inverse norm, it automatically fills in the 0 and the 1 for you. If you use these two up here, you have to fill in the mean. So we can go ahead and try this one here. So what is our z-score? It is 0.83. And then for cumulative, we want it to be cumulative. We will rarely ever use this PDF here. So we're going to go ahead and type in true. And you'll see that it gives us the probability of being less than 0.83 or z-score 0.83, or finding the area of this region. And then we go to 4 decimal places. So we put in 0.7967, and we can go ahead and check our answer. And we've got it. Now, if you wanted to do the same thing with the other option, so if we go back to our function again, and then once you use these, they'll be your most recently used. So you can use this other one here, the NormDist, but it looks for more information. So we're looking at, again, that 0.83 we had before, and then we have our mean and our standard deviation. And again, the other one with the S just does that for you. And then we're going to use true. And then we have the same, go back to this one, we have the same exact result. So it's just more information you have to put in. So then we're going to look and see what we want to do here if we have a range. So, okay, so it's the first one. So again, I always recommend drawing your distribution to see what you have here or what you're looking for. So in this one, we have a z-score of 0 and then up to 0.7. So we're finally finding the probability right here. Now, when we use Excel, when we find the probability, it's always doing the probability to the left. So when we go ahead and put in 0.7, it's going to find all this probability over here. So it's going to do all that probability. And then when we do 0, so put in 0 here, finding all the probability here. Now we don't even have to calculate this. If we're doing the probability to the left of 0, we already know that's 0.5. But if we wanted to find out and do it by hand, we could do that. So, or to use Excel. So again, if you haven't already called it up, because it's standard normal, we could use this one here. And if we have a z-score of 0, again, we're going to use true. You'll see that comes up 0.5. So we already figured that out, but we also want to find the probability to the left of 0.7, so we're 0.7 above the mean of 0. And for that one, we get 0.7580. Now, we're looking for this part here in the middle, so point to it right here. So what you're going to do is you're going to take that 0.7580 and then we're going to subtract off this part here that we don't want, this 0 here. So we're going to subtract off 0.5 and then we're going to end up with 0.2580. So let's see if we have another one here. Okay, so now we're switching off the standard normal to having a mean and a standard deviation, and we're looking to see being probability less than a value of 83 coming up given our mean is 90 and given a standard deviation of 4. Okay, so if we go back here, and again I always recommend drawing your normal distribution. And for this one, our mean here is 90. Okay, and if we were to go to one standard deviation above, we would get to 94. So I'm just adding 4, and I'm subtracting 4. So if you want to know where the z-score fits in, what you do is, so if you want to know the z-score associated with 94, we would take 94, and remember the formula is x minus our mean divided by our standard deviation, which is given in the problem. And then if you go ahead and do this computation, you get 1, which makes sense. That 94 is 1 standard deviation above. If we tried it with the 86, so we're doing the same thing. We're taking 86 minus our mean divided by our standard deviation, but this time we get a negative 4 over 4, which is negative 1, which tells us that if we had a mean of 0, 86 would be 1 standard deviation below. So we found the z-score here, and then this would be 1 above. So z-scores is just a way to translate it into a relationship. How far is away? So if you have a standard deviation of 4, you're 1 standard deviation away from 90 given this problem here. Now, before technology, we would have to go ahead and use those tables, but because we have technology, we don't have to use the tables. So what we're looking for now is 83. So we're looking at the probability that x is less than 83, which is over here. So we know it's somewhere over here, so that we know that our probability is going to be less than 50% because we're over here somewhere. Okay, so what we can do is go to function, and then we've been using these, so we can go to NormDist, so not the S, because we have to put in the mean and standard deviation, and we're going to go ahead and hit OK, and we're looking for our x is 83, and then our mean is given, which is 90, our standard deviation is 4, and then we put in true, and it gives us the probability. So it's a very small probability that we would get a value less than 83 given a standard deviation, or a standard deviation of 4 and a mean of 90. So round to 4 decimal places, so it looks like it would be 0.0401, and we'll check our answer. Okay. So we're going to go on to the next question. Okay, so again, we're looking at one that's between. So when we do a between, we would need to find both values and then subtract the probabilities. So for this one here, again, we're given a mean of 82, so there's our middle value, and then our standard deviation. I always like to throw 1 in. So I added 5, and I will subtract 5. So we're looking for the probability between 78. So we're over here somewhere. So this would be 78. And then 67 would be over here. So we're looking for the probability in between here. But if we use Excel and we looked at 78, it would give us all this probability. And then if we did 67, we would have less probability here. So we would take the difference between to get this amount right here in the middle. So again, if you've been using your functions, it'll be right there. So we have NormDist, and we were put in 78, and then the mean is given 82. There's a 5, and then we'll do true. So we're getting a probability of x being less than 78 is 0.211855. Now we're going to do the same for the 67. So now we're going to do 67, and then a mean of 82, 5, and then again true. And then we get a probability of 0.00135. So if we go back over here with our 67, this little probability here is 0.0014. This big probability here is our 0.21186. So we want to take the difference. So you just do it in Excel. So we're going to take this one, minus, and I'm just clicking on the cells that I want, hit enter, and then there is our answer. So we have 0.2105. Okay, so then we get into more word problem. So again, when you're looking at a normal distribution problem, you want to go ahead and make that curve. Some students like to skip this part, but I think it helps to visualize what we're looking at. So again, we know it's a normal distribution problem because we're given a mean and a standard deviation. Okay, so that tells us we have a normal distribution problem, and again, our mean is right in the middle, and then our standard deviation, if we added 0.2, that would be 1 away, and if we were on this side here, we would get 19.9. So we're skipping over finding the z-score. So, and most of these help buttons or whatever you're looking at is going to tell you to do the z-score and then look up the probability. If you're using Excel, we can skip the z-score and go directly to finding the probability. Okay, so behind the scenes, Excel calculates the z-score. It looks up the number for you, so you don't have to. All right, so probability of less than 12.1 fluid ounces. So 12 would be right to the left of this 12.1. Okay, so we know up to this line here, up to the mean, it would be a probability of 50%. So we're a little to the left, so we're looking for this probability over here. So we know what we're going to get. It's going to be a little bit less than 50%. So again, we're going to use this NormDist, and then we're putting in 12. Our mean is 12.1, and then our standard deviation is 0.2. And then we use true because we want all the probabilities, not just at a single point, and we hit OK, and we get 0.3085. So you want to be careful because when you put your decimals or your answers in, it's not very forgiving, so make sure you round correctly. And to do that, if you're in Excel, you can go ahead and use decrease, increase number. So this is increase, this is decrease, and you'll get it to 4 decimal places.